Welcome to today's Explainer. I am so incredibly pumped you're here because today we're looking at something that honestly just blew my mind. The absolute most sophisticated piece of biological technology in the known universe. And yeah, it's your own body. I mean, every single second there is this lightning-fast network of communications happening inside you, coordinating literally everything from the rhythm of your heartbeat to that sudden spark of a new idea. So today, we're decoding the human machine.
But before we dive into the deep biology, let me ask you something. Have you ever gone to type a familiar phone number or a passcode into a screen and your fingers just effortlessly tap it out without you even thinking? But if someone were to ask you to recite those exact same digits out loud, you completely freeze? Like, how on earth do your fingers remember a phone number better than your actual conscious mind does? Well, it's a super relatable mystery, and solving it means we get to follow the incredible journey of an action right through your nervous system. Okay, let's dive into this. Here is our roadmap for today. We'll start at the ultimate command center, then look at how we sense the outside world, check out our autonomic autopilot system, see how we translate thoughts into actual movement, and then we'll wrap it all up with the sheer magic of neuroplasticity. All right, let's kick things off with part one, the ultimate command center. Basically, the body's own smart home system. So deep inside your brain, there's this tiny but mighty structure called the hypothalamus. And it effectively acts as your central smart control. Its ultimate goal, well, it boils down to one absolutely crucial word: homeostasis. The hypothalamus is constantly, and I mean constantly, receiving chemical messages to maintain a super delicate internal balance. Whether it's adjusting your body temperature, telling you you're hungry or thirsty, tweaking your blood pressure, or even managing your sleep, every single system we're going to talk about today is ultimately striving for this biological equilibrium. And it's honestly amazing how the hypothalamus gets this done. It sits right on top of the pituitary gland and communicates with it using releasing hormones. Just look at this chain reaction. Say you need to grow. It releases a specific hormone that triggers the pituitary, which then fires growth hormones straight into your long bones and muscles. Or what if you're stressed? It sends a signal telling your adrenal glands to pump out cortisol to manage that stress. Or it sends TRH, so your thyroid releases T4 and T3. It's just a brilliantly efficient chain of chemical messengers working 24/7 to keep you balanced and, well, alive. Okay, moving on to part two, sensing the outside world. This is all about gathering the data. Because to maintain that internal balance we just talked about, your brain first needs data about what's happening out there in the world. And it turns out your skin is basically a massive, real-time data collection canvas. You've got mechanosensory receptors detecting light, touch, and tension, but the ones that really fascinated me are these things called Pacinian corpuscles. They are so incredibly fast-acting, they can detect tiny vibrations up to 250 hertz, but here's the kicker. They purposely ignore constant pressure, which is literally why you forget you're wearing clothes right now. Plus, you've got specialized nociceptors acting as your body's alarm bells for harmful pain, and thermoreceptors tracking hot and cold. But it's not just about what you touch, right? It's about knowing where your body actually is in space. We call that proprioception. To wrap your head around how vital this is, just imagine trying to comb your hair while looking into a mirror that's reflecting off a second mirror. That double reflection flips the image, so suddenly you're reaching left when you should be reaching right. That weird, frustrating disorientation, that is exactly what happens when your brain's visual input misaligns with its physical proprioceptive input. Your brain relies on all these systems perfectly syncing up just so you can pull off coordinated movements. Which brings us to part three, the autonomic nervous system. Your built-in autopilot system, or as I like to call it, the gas and the brake. All right, so with all that sensory data flooding in, your unconscious autopilot takes the wheel to regulate your vital organs using integrated reflexes. A great way to think about this is having two complementary pedals. On one side, you have the sympathetic division, the gas pedal. This is your fight or flight response. It kicks in super fast to divert blood away from digestion, shoves it right into your skeletal muscles, and dilates your pupils. On the flip side, you have the parasympathetic division, the brake pedal. This promotes rest and digest. It's a slowly activated dampening force that calms your heart rate, gets your digestion going again, and basically brings you back to a state of calm. Now, the really crucial thing to understand here is that this isn't just for extreme survival, like, running from a bear. It is a second-to-second modulation keeping you upright. Literally, just the simple act of standing up from a chair triggers a sympathetic response to bump up your blood pressure so you don't pass out. Even your normal, everyday breathing cycles are constantly tweaking your heart rate using both of these systems.
Oh, and get this, because it's absolutely wild. There's an entire subdivision called the enteric nervous system that operates almost entirely on its own down in your gut. It uses 200 million neurons just to manage your digestion. Your autopilot is a powerhouse, and it never, ever clocks out. So we've got the automatic stuff down. Let's head into part 4, translating thoughts into movement, how we go from brain to muscle. How do we actually take all this data and turn a voluntary, conscious thought into a physical action? Well, it's a lightning-fast biological relay race. Say you just decide to do something simple, like fold a piece of paper. Step 1, that intention is processed up in the brain's premotor and supplementary motor areas, which figure out exactly which muscles need to fire. Step 2, that command shoots down the superhighway connecting your brain to your spinal cord, called the corticospinal tract. And step 3, the signal exits the spine, hits the exact right nerves and muscles, and boom, you fold the paper. And the specific location where those commands exit your spinal cord, it is highly, highly organized. Think of the spine as this vast distribution highway for your whole body. At the top, you have 7 cervical levels branching out to control your breathing, neck, and arms. A bit lower, the 12 thoracic levels handle your chest and torso. Keep going, and the 5 lumbar levels take over for your legs. Finally, right at the bottom, the sacral levels control bowel, bladder, and sexual function. So the exact exit point on this highway dictates exactly which part of your body gets the message to move. Which circles us all the way back to our opening mystery. How do you dial that phone number without thinking? Well, as it turns out, when you first learn a motor skill, your brain uses a ton of conscious, focused attention. But as you repeat it, your nervous system starts building statistical expectations. And then, while you sleep, these practiced movements transfer out of the conscious cortical areas of your brain and get stored as loops deep in your cerebellum and basal ganglia. Your brain literally chunks these fluid sequences together and just hands them off to the automatic systems. That is a muscle memory in action, and it's exactly why your fingers can punch in a passcode perfectly while your conscious mind is off thinking about something completely different. And all of that leads us perfectly into our final section, Part 5, the power of neuroplasticity, basically how the brain upgrades the system. Because this ability to form muscle memory relies on arguably the most magical feature of the nervous system, neuroplasticity. Your brain literally upgrades its own hardware. It's not some static machine, it is a dynamic, living network that relies on a triad of adaptation. First up, you have synaptic pruning. This is where the brain acts like a gardener, actively trimming away unused connections just to make room for faster, more efficient pathways. Second is long-term potentiation, or LTP, which fortifies and amplifies the connections you actually use a lot. And third, it undergoes real physical structural changes. We're talking dendritic branching, or even neurogenesis, the actual birth of entirely new neurons in the hippocampus, which is just continually fueled by cognitive stimulation. If we zoom in on these synapses, you see this beautiful, continuous interplay. Long-term potentiation means that when you repeatedly activate a pathway, say practicing chords on a guitar, that connection gets stronger and solidifies the memory. But right alongside that is long-term depression, or LTD. If you stop using a pathway, reduced stimulation actively weakens that synapse. And you might think weakening is bad, right? Actually, scratch that. It is absolutely essential. Weakening the unused pathways is what refines your neural networks, ensuring your brain's precious energy is only spent on the connections that matter most to you right now. I really love how our source material summed this up. It says, the brain, akin to a masterful sculptor, adapts its architecture, refining neural connections to optimize functionality. Just take a second to think about that. Your brain isn't just the clay being molded, it is the sculptor itself. It has this incredibly resilient, regenerative potential to physically reshape its own destiny based entirely on what you experience and what you practice. And that brings me to one final empowering thought I want to leave you with today. We've explored how your command center works, how it gathers sensory data, runs the autopilot, translates thought into physical movement, and then literally reshapes itself through neuroplasticity. So if your everyday experiences literally rewire the physical structure of your nervous system, what new pathways will you choose to sculpt today? Think about it. Thank you so much for joining me for this explainer, and I absolutely cannot wait to explore our next topic with you. See you then.